Good day, I am Brian Dave Gastok, and it's nice to see you in this video again. So for today's video, we will gonna have another video tutorial in solving linear programming, specifically using the different methods, which is the northwest corner method, the least cost method, the Vouchers approximation method, with the Hdij or UV method in solving transportation problems. So now, join me and let's start. So we have here transportation problem. Below is the table of transportation problem with 3 sources of goods to be delivered into 4 destinations. We have sources A1, A2, and A3. Destinations 1, 2, 3, and 4. We have also supply and demand. So in transportation problem, we need to verify first if the total supply and the total demand are the same in number or sum. So the total supply, we have here 200 plus 200 plus 300 is equal to 700. The total demand 150 plus 200 plus 250 plus 100 is equal to 700. So as you observe, they are equal. So 700 for the demand. So since both the total supply and demand are equal, then the TP is balanced. So if the transportation problem is balanced, we can now proceed in finding the initial basic feasible solution. So in finding IBFS, we have 3 methods. So the northwest corner method, the least cost method, and the Vouchers approximation method. So after finding these 3 methods, so we will choose one method that will be used in optimality test or Hdij or UV method for testing the optimality or the minimum cost of transportation. So an optimal solution is one where there is no other set of routes allocations that will reduce the transportation cost. We have to review the unoccupied cells of the initial solution. So an occupied cell with largest negative opportunity cost is selected for inclusion. Concept is similar to simplex method for entering and leaving variables and iterations, and when no more negative opportunity costs exists.
So now we will solve the transportation problem using the 3 methods in finding the initial basic feasible solution. So first we will solve using the northwest corner method. So in northwest corner method, we will see the table and we will allocate in the northwest corner. So the northwest corner in this table is in cell 8. So we will allocate here. So since we have 150 as the demand and supply is 200, we will find the lowest value. So we have here 150 to be allocated here in this cell. So 150. So 150 minus 150 is equal to 0. And 200 minus 150 is equal to 50. Okay. So since it is already 0, so this column will not be allocated anymore. So we will cancel these values. And so where now is the northwest corner? So it's in cell where 6 is to be found. So looking at the supply and demand, so we have here 50 and we have here 200. So the smallest number is 50. So we will allocate 50 here. Okay. So since we will subtract 50 here, we will have a 0 value in the supply. So since it is already 0, we will no longer allocate this row. So 200 minus 50 is equal to 150. So let us continue the allocation. So we will find the northwest corner since it's not to be allocated. So we will find the northwest corner here. So it's the cell where 7 is to be found. And we have here 150 as our demand and supply is 200. So 150 is the smallest number. So we will allocate 150 here. So 150 minus 150 is 0. So 0. So since it's already 0, so we will no longer allocate in this column. So 200 minus 150 is equal to 50. So since this is not no longer allocated, so this corner where is the northwest, so it's in the cell where 13 is to be found. So 50 and 250. So 50 is the smallest, so we will allocate 50 here. And then 50 minus 50 is equal to 0. So since it's already 0, we will no longer allocate in this row. So 250 minus 50 is equal to 200. And now we were left with two cells where 11 and 13 is located. So we will locate the northwest corner, and it's in the cell where 11 is to be found. And we have here 200 and 300 as a supply. So we will allocate 200. So 200. So we will cancel. It will become 0. So since it's already 0, we will no longer allocate this corner. And 300 minus 200 is equal to 100. So we were left with one cell only. So we will allocate this cell. So since 100 is the remaining supply and the demand also is 100, so we will allocate 100. So, and we will cancel, so it will become 0, and this one will become 0. We have the occupied cells 1, 2, 3, 4, 5, 6. And the occupied cells is equal to the equation m plus n minus 1. So we have here m as our resources, 1, 2, 3, plus our n, our destination, 1, 2, 3, 4. Minus 1 is equal to 6. And the occupied cells is equal to 6. So we will calculate the product of these allocated cells and afterwards the sum of this.
So we have
8 times 150 plus 6 times 50 plus 7 times 150 plus 13 times 50 plus 11 times 200 plus 13 times 100.
So using the calculator, we can get the value of 2,700. So that is the minimum cost or initial feasible solution using northwest corner method. So let's now proceed with least cost method. So in the least cost method, we will find the least value here in this table. So we'll allocate in the least value. So we have 4 as our least value. So we will allocate in this cell. So 200 and 300. So where is the smallest number? So it's 200. So we'll allocate 200 here. So 200 minus 200 is equal to 0. So since this column is already 0, so we will no longer allocate in this column. So 300 minus 200 is equal to 100. So we have remaining 100 here. So we will find the another least cost. So we have here 5. So we will allocate in this cell, in this corner. We have 150 and 200. So 150 is the smallest, so we will allocate 150 here. So 150 minus 150 is equal to 0. So since this is also 0, so we will no longer allocate this column. So 200 minus 150 is equal to 50. So we have here 6. So we'll allocate here in this cell. So 150. So 50 is the least number. So we will allocate 50 here. So we have here 0 and 50. So since it is already 0, we will no longer allocate in this row. So next is 10. So we'll allocate here 250 and 200. So it's 200. So we'll allocate 200. So 200 minus 200 is equal to 0. 250 minus 200 is equal to 50. So since this is already 0, so we will no longer allocate in this row. And we were left with 2 cells, and the smaller value is 11. So we will allocate here in 11. So 50, 100. So we will allocate 50 here. 50. So 50 minus 50 is equal to 0. So since this is already 0, so we will no longer allocate in this cell. And 100 minus 50 is equal to 50. So we were left with only 1 cell, and we will allocate here. So since it's 50 and 50, so we will allocate 50. So 50 minus 50 is 0, and 50 minus 50 is 0. So we get the occupied cells 1, 2, 3, 4, 5, 6. So Same with the northwest corner method. So
m plus n minus 1 is equal to 3 plus 4 minus 1 is equal to 6. So our occupied cell is equal to 6.
So we will solve for the sum of the product of these allocated cells. So let's start.
Okay, 10 times 200 plus 5 times 150 plus 6 times 50 plus 4 times 200 plus 11 times 50 plus 13 times 50.
So using the calculator, we can have the value of 5,050. So in least cost method, we get the value of 5,050, and it is smaller than this value. So now let's proceed with the Vouchers approximation method. So as you can see, it's quite tricky here in this method, but we will start with the explanation. So this is row difference and the column difference. So it's very easy to get the row difference and the column difference. So in this row, we will just get the smallest value and the second smallest value. We'll get their difference. So 8 minus 6 is equal to 2. So we have here 2. In this row, so we have here 5 is our smallest value, and we have here 6 is the second smallest. So the difference of the two is 1. So we have here 10, 4. We have 4 the smallest value, followed by 10. So 10 minus 4 is equal to 6. So next in this column, so we will find, so same process here, we'll find the smallest value of this column, which is 5, and the second smallest is 8. So 8 minus 5, or the difference of the 8 and 5 is 3. Is 3 here. Okay. And the next column is, we have here 4, smallest, and we followed by 6. So the difference between 6 and 4, 6 minus 4 is equal to 2. So here we have smallest of 10 followed by 11, so the difference is 1. So this 6 and 12. So the difference between 6 and 12 is 6. So since we found the row difference and the column difference, we will find which is the largest number. So we have here 6 and 6. So we will choose where to allocate. So we will circle this one. We will choose this one. So in this row, where is the smallest value? So it's 4. So we will allocate in this cell. So we have here 200 and 300. So we will allocate the smallest. So it's 200. So 200 minus 200 is equal to 0. So since it's already 0, we will no longer allocate in this column. So 300 minus 200, we left with 100. So since we will no longer allocate in this column, so we'll put dash in here. So let's go back here. So in this row, which is the smallest, so it's 8, and the second is 10. So the difference between 8 and 10 is 2. Next column is, where is the smallest? So it's 5. Next is 6, so it's still 1. So in this row, we have 10 and 11. So the difference is 1. So in this column, we have the difference of 5 as the smallest, and to be followed by 8. So the difference between 8 and 5 is still 3. And this is 10 and 11. So the difference is 1. So here, 6, next is 12. So the difference is still 6. So now, since the largest value is in this column, so we will encircle 6, and we will find the smallest value here. So it's 6. So we will allocate in this cell. So we have here 100 and 200. So 100 is the smallest. So we'll allocate 100 here. And 100 minus 100 is equal to 0. So since it is already 0, so we will no longer allocate in this column. So 200 minus 100 is equal to 100. So since it is already no longer been used, so we will put dash here and here also. So same process, we will find the smallest. So it's 8, and then 10 is the second smallest. So the difference is still 2. So next, 5 is the smallest and followed by 13. So since it's already crossed out, so the difference is we have 8. And we have this row is 10 and 11, so it's still 1. In this column, we have a smallest value 5 and followed by 8, so it's 3. So we have here 10 and 11, so the difference is still 1. So as you can see, where is the largest number? It's the 8, so we'll allocate 8 here. So we will find the smallest value, it's 5, so we will allocate in this cell. So we will allocate 100 and 150, so it's 100. And 100 minus 100 is equal to 0. So since it's already 0, so we will no longer be allocating this row. So we'll put dash in here. And 150 minus 100 is equal to 50. So to continue, same process as still. So the difference between 8 and 10 is still 2. And this is 10 and 11, so it's 1. So this column, we have 8 and 10, so we have 2 as the difference. And this one is, and here 10 and 11 is still 1 and no longer to be allocated. So where is the largest number? So we have two largest number, 2 and 2. So in either way, we will choose 2 here and 2 here. We will allocate in this smallest, so we will put 2, or whatever you choose in this largest number. So it's still, we will allocate here in 8. So you have here 50 and 200, so we'll allocate 50 since it is the smallest value. So 50 minus 50 is equal to 0. So since it's already 0, so we will no longer allocate in this column. 200 minus 50 is equal to 150. So as you can see, there's 2 cells left and we will choose the least number, so it's 10. So we'll allocate here in this cell. So 150 and 250, so it's 150, the smallest number. 150 minus 150 is equal to 0. So since it is already 0, so we'll no longer allocate in this row. So this one is the last cell that's to be allocated, so we'll allocate this cell. I mean, oh yes, 250 minus 150 is equal to 100. So this cell is, we have 100 and 100, so we'll allocate 100 here so that we can have it 0, and this one also 0. And we'll no longer allocate that one. So we have balanced supply and demand. So just like the two methods, so we will count for its occupied cells, 1, 2, 3, 4, 5, and 6. So
m plus n minus 1 is equal to 3 plus 4 minus 1 is equal to 6, and our occupied cells is equal to 6.
So we will add the product of this allocated cells. So we have
8 times 50 plus 10 times 150 plus 5 times 100 plus 6 times 100 plus 4 times 200 plus 11 times 100.
So using the calculator, we will calculate the total sum of this equation. So we get total of 4,900. And that is for Vouchers approximation method. And as you can observe, this feasible solution is much smaller than the amount than the two methods. So that's it. So now let us solve for Hdij or UV method. So the steps of Hdij or in solving Hdij is step 1, form an initial solution using any of the 3 methods. So we chose Vouchers approximation method since it results the smallest feasible solution. So here, the second step is to calculate UI and Vj for rows and columns for an occupied cells and use the relation Cij is equal to UI plus Vj. So for
Occupied cells, we will calculate for UIs and VJs using Cij is equal to UI plus VJ formula.
So first we will let U1 is equal to 0. So this is 0. So we will put C. So the occupied cell is in here in 8. So in row 1, column 1. So C11. And using the formula, we will calculate for our V1. So V1 is equal to
C11 minus UI.
So we just equate the formula to get this equation. So we have C11, so it's 8. So our Cij is 8. So we have 8 minus our Ui is equal to 0. So is equal to 8. So our V1 is equal to 8. So next allocated cell is here. So we have row 1 and column 3. So C13. And we have V3. So we will find the V3 is equal to
C13 minus UI. UI is equal to
V3 is equal to C13 is equal to 10 minus our value of U10. So it is equal to 10. So our V3 is equal to 10. So our next occupied cell is in row 2, column 1. So C21. So since we have V1 already, and so we will put V1 here 8 and our V3 as 10. Sorry for that. Okay, since we had the value of V1, so we will find the value of our U2. So U2 is equal to
C21 minus V1 is equal to.
So our value of C21 is 5 minus 8. So it's equal to negative 3. So our U2 is equal to negative 3. So we have here negative 3. And next we have the row 2, column 4. So C24. So since we have the value of our U2, we will find the value of V4. So V4 is equal to
C24 minus U2 is equal to.
The C24, this we have 6 minus U2 negative 3. So we have here plus. So 6 plus 3 is equal to 9. So we have our value of V4 equal to 9. So we'll put 9 here. 9. So next we have, since we have values from V2 and U3, we will first calculate for this cell. So C row 3, column 3. So C33. So since we have value of V3, so U3 is, we will going to find the U3. So
C33 minus V3. V3 is equal to.
So we have 11 minus 10. So we have 1. So the value of our U3 is equal to 1. So we'll put 1 here. Okay. So last one is V2. So it's C row 3, column 2. So we'll find V2 is equal to C32 minus the U3. So U3 is equal to, our C32 is 4 minus our U3 is 1 is equal to 3. So our value for V2 is equal to 3. So we just found the UIs and VJs. So our U1 is 0, our U2 is negative 3, our U3 is equal to 1, and our V1 is 8, V2 is 3, V3 is equal to 10, and our V4 is 9. So this is for our occupied cells. So next step, for step 3, for unoccupied cells, calculate the opportunity cost using Dij is equal to Cij minus Ui plus Vj. So we have here, okay, so
For unoccupied cells, calculate the opportunity cost using this formula.
okay, we will start with the row 1 and column 2. So it's P1, 2. So using the formula,
Dij is equal to Cij minus Ui plus Vj.
so finding for Cij, we have 6. So 6 minus our Ui is 0. Our Vj is 3. So plus 3. So it is equal to 3 plus 0 is equal to 3. 6 minus 3 is equal to 3. Okay, so next we have this cell. So it's in row 1, column 4. So we will put P14. So formula
Vij is equal to Cij minus Ui plus Vj.
is equal to, so our Cij is equal to 12. So 12 minus our value of Ui is 0 and our Vj is 9. So 0 plus 9 is equal to 9 plus 0 is equal to 9. 12 minus 9 is equal to 3. Okay, next unoccupied cell is 7. So we will put here because it's in row 2, column 2. So P22. So our Cij is equal to 7 minus our Ui is equal to -3 and our Vj is equal to 3. So we'll put -3 plus 3 as our Vj is equal to 3. -3 plus 3 is equal to 0. 7 minus 0 is equal to 7. Okay, next unoccupied cell is here. So it's in row 3, column 3. Row 2, column 3. So we have P23. Okay, our Cij is 13, our Ui is -3, and our Vj is 10. So 13 minus -3 plus 10. So -3 plus 10 is equal to 7. So 13 minus 7 is equal to 6. Okay, so next an unoccupied cell is 10. So this is in row 3, column 1. So it's in P31. So our Cij here is 10 and our Ui is 1 and our Vj is 8. So we'll put 10 minus 1 plus 8 is equal to, so 8 plus 1 is equal to 9. So 10 minus 9 is equal to 1. Okay, so the last unoccupied cell is here in 13, in row 3, column 4. So we have P34. Ij is equal to 13. Our Ui is 1 and our Vj is 9. So we have here 13 minus 1 plus 9. So 9 plus 1 is equal to 10. So 13 minus 10 is equal to 3. So we just calculated the unoccupied cells using this formula. So step 4 is to examine each Dij. So we have here the condition. If Dij is greater than 0, then the current solution is optimal. If Dij is equal to 0, then the current DFS will remain unaffected but alternate optima exist. Last one, if one or more cells have Dij less than 0, then an improved solution can be obtained. So looking at the values of our unoccupied cells, since it's all greater than 0, then it only means that since all Dij is greater than 0, then the current solution is optimal. Is optimal. So since it turned out that our current solution is optimal, then our minimum cost of transportation is equals to 4,900, as it is the value for our Vouchers approximation method.
And there you have it, guys. Thank you for listening, thank you for watching, and I hope you learned something in this video. See you again in the next video. God bless everyone, and bye-bye.